Okay. Um, if you guys remember yesterday, we left it at isolated grounding receptacles. And why do we use isolated grounding receptacles? By the way, the plan for the day, before I start, I have 3 things for you today. Well, 4 things. I want to finish this PowerPoint presentation. And after that, I'm going to review for the theory, tell you what's expected on the test for the theory. And I do have review for the calc. Review for the theory, review for the calc, and this chapter. And the fourth one, guys, we're going to continue doing circuiting. I'm going to keep my smartboard up and running so we can put Revit there. If anybody best practices in Revit, how to circuit and all the stuff. So I'm going to keep my Revit up and running at the smartboard later on. Okay, why do we use electronic equipment grounding, guys? The isolated ground. There's a whole list of offenders, Brad, that can screw up your computer system, from static surges into sags and voltage spikes and so forth. You'll have to remember that one. Lightning is a major one. Radio frequency interference, EMI. What does all these do, guys, to you? If I want to type A, if I decided to type A and it looks on the computer B, basically. Corruption of data. That's kind of an extreme, but corruption of data. You want to type 10,000, you type 10,000 on a keyboard and it shows up as 1,000. Well, you don't want that to happen, especially if it's your account, checking account. So that's why, guys, we use the isolated ground. And we said yesterday, it takes all these interference direct away from the electronic equipment. That's why we ground the electronic equipment with insulated ground all the way to the main panel. So to solve the disturbances, so that was kind of a couple of issues. Okay, ground fault interrupters. A couple of things, guys. We know that electronic equipment, we're gonna have the neutral, the ground, and isolated. I wanna emphasize a few things about this in particular. Ground circuit interrupter protection. We all know that GFCI is supposed to protect you from touching the hot and the ground. In a commercial building, there's a places where you need a GFCI on a 15 amp. Remember, we're not talking about residential. Residential, we know it. But in a commercial building, if you have a sink, if you have an outside receptacle, if you have a bathroom, all these locations, wet locations, have to be GFCI protected, any receptacles that you have. So keep in mind, 2 ways of GFCI, Brad, as you know, either receptacle or circuit breaker. Receptacle or circuit breaker. So that's basically what I want to emphasize in that particular slide. Ground. A couple of things where this is important, because this is commercial, guys. Where do you need a commercial GFCI receptacle? I thought this is really interesting. Again, from article, can't recall the article. So I want to emphasize this one. I want to emphasize that we're only looking at 15 and 20 amp, and Spencer, we're only looking at 120 volts. So if you have 15, 20 amp, or 20 amp, 120 receptacle, here's the location that you need GFCI in a commercial building. Very important. You need them in every bathroom. Spencer, do we have a bathroom in our building? Yes, we have 2. So these receptacles have to be what? GFCI. Kitchen, do we have a kitchen in the bathroom in our building? You can argue what's the definition of a kitchen? A permanent place to cook. So that's, I don't think that the lunch area qualifies as a kitchen. Is it a good idea as engineers to put the GFCI receptacle on the countertop of a kitchen, even though it doesn't qualify as a kitchen? Yes. So the receptacle ties on the countertop in our project, though it might not, it's a lunchroom, it might not qualify as a kitchen because it has a sink, but it doesn't have a permanent place of cooking. That's what a kitchen is. Still, in our project, please do put a GFCI in the countertop receptacles. Rooftops and outdoor, of course, and within, that's what the only add, with some exception. If you have a sink, any sink in a commercial building, any sink within 6 feet receptacle, please put a GFCI. Everything that you guys can see is a code, and so forth. If you're doing replacement, we don't do replacement, we do design. If you're doing remodeling, Ryan, in the company that you work for, and there's a countertop kitchen receptacle, you need to replace it, remodel it, then you have to have a GFCI. So that's what this replacement deal tells you. Any location in a commercial building that needs a GFCI and you need to replace that GFCI, non-GFCI receptacle, replace it because of defect, you have to put a GFCI receptacle. Any question guys about this? I can't emphasize this is non-residential. I'm not going to review the residential with you guys. You're very familiar where in residential we need a GFCI. There are two words for residential, for one word guys, almost common between all these locations. Wet. Any wet location, almost anywhere, you need a GFCI. There are some exceptions. If you're cooking nuke at the U of M, in a lab, and you're cooking some nuke and you are within a 6, there's a sink over here that you put, I'm not saying nuke or chemicals, you're doing some mixing chemicals, dangerous, and you're right here within 6 feet, guys, that receptacle does not have to be GFCI. The receptacle in a certain application where the application is very dangerous, even though it might be 6 feet from a sink, but it doesn't have to be GFCI. For the most part, all receptacles have to be GFCI. Any questions about this? Added 2011, Brad, the GFCI have to be readily accessible, so I don't have to climb right over my desk to reset this GFCI. Okay, so that's basically what this. If you use a baseboard heaters, you might in a commercial building, guys, somebody's office is so cold because the mechanical engineer screwed up the heating cooling system, so they put a baseboard heater. Normally you don't do that, but you might have a situation where baseboard heater is your application. You can have, and you need a receptacle in that location for whatever reason. That receptacle in the baseboard heater, you can put it as part of the structure of the baseboard heater, but you have to feed it from an independent circuit. So that's what this is telling you. So if I have a baseboard heater, here's a picture, guys. It's like a residential. Here's my receptacle over here. I have 2 circuits. I have 1 circuit feeding. This is circuit number 1 feeding my receptacle, and I have another circuit here, circuit number let's say 24. It's a 2-pole circuit that's feeding this 240. This will be a 240 baseboard heater, and this will be a receptacle. You don't feed them from the same circuit. That's really the same type of residential. No change in residential. Now, Brooks, my friend, the rules of 6/12, does the rules of 6/12 for receptacle layout apply for a commercial building? The answer is always no. So 6/12 rules of laying out receptacles in a commercial building or other than residential does not apply.
If you add another receptacle on another side, you have to go in another circuit too. You can't run up through.
Yeah, you can't use this as a conduit. Right. You can't use this. You're right. So you have another receptacle in this area. You cannot pull your conductor, use this as a conduit. So, or you can come from here though and go up. It looks ugly, but yeah, absolutely. You don't want to use the heater frame or enclosure as a conduit. Any question, guys, about this? Any question about this? Unless it's listed. If they give you, I don't think they give them list at the bottom where they give you a channel to pull your conductors. You just don't want to put conductors inside the heater enclosure. Okay, snap switches, guys, the toggle switches that you have. The only thing I want to mention about the snap switches, this is what the snap switch that we're talking about right here. There's a few changes. There are 2 types of them. The most common type that we're using is this boy here. AC general use snap switches. There's also, you can get them AC, DC. You can land AC or DC on them. Toggle switch is the common term that we use with that. So it's a device, guys, to turn on and off safely a load. On and off safely a load. Only most of them are lighting load. If it goes, guys, if you want to use the snap switch on a motor, there's some restrictions how big on the motor has to be, 300 volt if I remember right, or less. So a few things that you have to keep in on the snap switches. Snap switches, the yoke must be grounded. In 2005, I believe, the yoke, everybody knows the yoke. I don't have a switch, but the yoke, here's the yoke. The yoke must be grounded, right? They added this one, if I remember probably in 2006. The metal box also have to be grounded. If you're using MC cable or AC cable, it depends upon the shield with the AC cable with that little stripe, ground the box and the device. MC cable have its own ground. This is interesting, might be on the test tomorrow. Secured, this particular one, secured to metal box by screws. If your yoke snap switch is considered grounded, it's grounded. If you have a metal box and yoke is snap switch is attached to the box, guys, to the metal box, then it will be considered grounded. It will be considered grounded. You don't have to pigtail it in a metal box. So that's interesting. Another one, the name, the metal faceplate, which most of the commercial, not most, some of the commercial will have a metal plate here. That's also considered grounded as long as it's attached to the yoke and the box. This is more if you're going to be, guys, a project manager and you kind of inspect the building before the inspector walks in. So it makes your company look really good instead of the inspector come up with a to-do list of or a checklist of 25 items to correct. You as a project manager, you can walk around and inspect the building before you get your inspector. Makes you look good, or your company. Conductor installation color for connection. Okay, so when we have the switches, guys, the idea of the switch is usually you have a black and white. There is, if you have a conduit like this, if you're a conduit system, you can pull any color you want with switches. With switches, we can identify switch return. This is what I want to emphasize, that particular one. If you are wiring, with boxes, here's my box over here, here's my conduit, and here's my light. My conduit is coming directly to my light, and then these are conduits, remember. Then I bring my hot here, here's my switch, break the switch, and bring my other hot, and my other conductor. Look at the colors, all the way to the light, and from here, here's my circuit going here. This is hot 1 or phase 1, and my light, this will land on my light, and my neutral, I want to put my neutral is landing here. So that's how you do it in a conduit, guys, right? Because you can pull color-coded conductors. If you have a cable that's in a conduit, you have to pull other than gray, white, and green conductors for your switches. If you have a cable, you have no other option. If you have a cable, if you're wiring with cable, like we did in residential, I don't know if you guys remember that one. Here's my switch here, and this is a cable. Remember, that's a cable. And here's my light. I'm wiring with a cable, MC cable, AC cable, and that's a cable. I can't emphasize that one. And then I'm going to be coming, the idea is, here's my neutral coming to the light, my neutral. Here's my phase A, coming to this fixture. The idea, guys, is to bring the white. I want to identify that one. You bring the white, tie it to the hot, bring it to the switch, one side of the switch. The other side of the switch, here's my switch here, it's going to be, the other side of the switch is going to be, say, the black going all the way back to the fixture. If it's a cable, the white have to be the one that brings the power to the switch. That's on a test tomorrow, guaranteed. That particular one. The white conductor or the gray conductor is going to be the one that brings the power to the switch. The switched leg has to be any other color other than white, gray, or green. Very important. So this color here must be a white. Well, not must be, but in this combination has to be a white. This color, black. And of course, this color is white. I identify it, and this color, black. You might ask, Brad, why are we doing re-identifying these when we're dealing with cables? Keep in mind, guys, you can wire with MC and AC cable the whole building, a commercial building. Doesn't have to be raw mix. You can identify AC, MC cable, SC cable, especially AC and MC cable. You can wire the whole Dunwoody here with MC, AC cable without a whole lot of conduits.
So why would you have to run the white wire to power it?
Because the conductor has two colors, black and white and ground.
Both hot.
Both.
Black and the white are both hot. So why does that do?
Because that's what the code says. You don't want to end up with two whites at the fixture. That's what it is in residential. When you have to re-identify the white conductor as a hot conductor, because white conductor are not supposed to be connected as a hot conductors. So you need to re-identify them because now they are carrying current as a hot conductors, right? So re-identifying them, the procedure of re-identifying them as always, you have to re-identify again. Meaning, put a tape, a black tape.
Yeah, I understand what it means, but
Why would you do it?
if you've got black coming in to the power and white coming out, you can still re-identify the white as hot as you're out instead of you're in.
So what you're saying is you bring the black tie here and take the white back to the fixture?
You know, I mean, what
The
difference
code-
does it make as long as it's identified?
The code say don't do that.
Okay.
That's all. It will work perfect. Here's how their argument is. The argument is you don't want to end up with two white conductor across the lighting fixture. Because if you do it the other way, you're going to end up with two white conductors across the lighting fixture, right? They don't want you to do that. Why? Anybody can come up, Spencer? Mr. Bew?
As far as code goes, all boxes, unless there's a raceway, has to have a neutral wire in it, switch boxes for lighting.
Thank you.
Right? So if you use MC, you technically couldn't do that.
MC, thank you. That's 2011. Now in 2011, guys, we got a big whole monkey jumping on you. In 2011, every switch that switch a light in 2011, NEC 2011, you have to provide a neutral to the switch. So what I'm doing right now, I can't do it in 2011. This is only good for 2008 code. What do I need to do then, Spencer? Guess what? I need to bring a 3-conductor cable instead of 2-conductor cable. Very important, but that's 111. Very good point. But you have to know that, guys, because you're going to be designing this. What I showed right now, it would almost become obsolete, re-identifying them. Not obsolete, almost. I'm going to say almost because there are other scenarios that you can do because you need a neutral on the ground in the switch right now. How do you bring a neutral to the switch? I bring a 3-conductor cable instead of a 2-conductor cable. This is a money-saving process. So, any question guys about this? Any question? If you're using conduits, you cannot identify. If you're using conduits, I can pull any color. Yeah. But MC and AC cable, guys, you can wire a whole lot of building with MC and AC cable. Okay, 3-way switches. Just a quick review, guys, for the 3-way switches. Mr. Urbab, 3-way switches always have 3 conductors. You have your travelers on one side, you have the common on the other side, and when you wire, and I hope for Pete Ricard's sake, that you guys can come over here and grab these two together, right, when we wire them. And if I have my fixture sitting right in here, Mr. Urbab, now, the first thing you're going to tie the two together. The third one, now which switch, and here's my neutral coming to my fixture. Oops, let's use a color that's
Stuck that forever.
doesn't want to wait. Okay. It's not identifying. Okay, so here's my neutral. Ignore the red. And then and here's my hot. My hot is coming here. Look at that example, huh? My hot is coming in here. And then how are you going to tie? And here's my switched hot. How are you guys going to tie these together? So I have my neutral tied. These two are for the fixture, terminal for the fixture. This is just a terminal, a wire now. How do you connect now to turn this light from two locations? How do you connect? Which side do you go? Does it matter? Does it matter which side? Okay, you're going to tie this system to this. There's power coming to the fixture, and there's 2 3-way switches connected together. You're going to wire it. How do you wire this? Where do you want to land this point? This point, where do you land this one? Here? You have 2 options, here or here. Which one? Yeah, okay, so perfect. So I bring this one here. And then if I bring this one here, guys, where does this must go down? Right here. Can I do it the other way around? Yes. So the most important thing with 3-way switches, guys, is that travelers tied together. The common can go either to the switch, either to the hot, they're bringing the circuit to the circuit, or to the lighting fixture. That's basically what I'm trying to illustrate here. Questions? No? Snap switches, 3 types. The most common ones are the first 3. In commercial building, guys, you're going to be a single pole snap switch. You're looking at it right there. You can have 3-way switch, 4-way switch. In a commercial building, guys, 3-way and 4-way switch becomes obsolete because we need more control to a lighting system in a commercial building than a residential building. So we use a low voltage control system, which eliminate the use of a three-way and four-way switches. Just FYI, if you have a low voltage control system, you can turn on and off a relay from as many locations as you need. But if you want a cheap design, high voltage switches, your options are single pole switch, in here. You're going to have 2 poles, three-way switch, as we said here, or four-way switch. 2-pole switch, guys. The 2-pole switch, this one, if you want to switch 2 fixtures with 2 hots, here's my terminal here, and I have 1 set of light, another set of light, and I'm going to, this set of light here, another set of light over here. So I have 10 lights here and 10 lights here, 2 circuits, and they're sharing a neutral. And each one of these circuits is coming from a 20 amp. Here's another 20 amp tied together because they're sharing neutral. This is a great application for a 2-pole switch, where you can, with one hit, Brad, you can turn 2 circuits off. 2 circuits. That's where the 2-pole is. If it's 1 circuit, it will be waste of money to do it on a 1 circuit. That's a great application if you want to do this. And that will give you, say, if we decided how many lights we're going to put based on our calculation, Ryan, I think 19. Based on our calculation, we said we can go as high as 19. Here's 19 fixture here, and with one hit, I can turn 19 plus 19 is 36. Fixture on and off. 38. Thank you. 19 plus 3, 9 plus 18. Okay, 38. 38 fixture with one hit. If that's an objective. But keep in mind that this is an option. Or you can use it other than lights. Any questions about this? Any question, my friends? So that's what we wanted to do. Conductor color coding is very important, guys. Color coding for conductor is very important. I will review it one more time and say for the grounded conductor, the ungrounded conductor, the most important thing is the green, usually green. It's going to be, or bare conductor, or bare. These are going to be your equipment grounding conductor. If you have white or gray, for the most part, this is going to be your neutral, which is the grounded conductor. Any other color than these could be the ungrounded conductor. That's kind of for the most part. There's some exception and so forth. So here's the exception is ungrounded conductor. These are the phase A, phase B, and phase C. You can use any finish that does not have a green or a white or a gray, or with 3 continuous stripes, white stripes too. You cannot use these as a hot conductor. Okay. Okay. So this is on a test tomorrow. The one I'm going to highlight now is in a test tomorrow, guaranteed. Popular colors, not by code. Popular colors. You can use pink if you want to, as a phase A. You can use pink as a phase A if you want to. Here's the popular color, guys. We have black, white, red, blue. Black, white, red, blue, up to these. So this will be popular for 208/120 3-phase system. 3-phase, okay? So you're going to have black, red, blue, white. Black, red, blue, white. These are your phase A, phase B, and a neutral. And what's the green? The green is coming for all of them. The second set, which is popular, is this guy with these. These together make the 480/277. The system. Here's what I'm talking about, guys. I do have, I have black, blue, and I have my red. This is the 3 colors that they use for 208/120 3-phase system coming. You don't have to, it's not good. And for the 3-phase 480/277, these are the color that they use. Now the ground, this guy can be used with either system. Green or bare conductor can be used with either system. The neutral of 208 commonly white. I don't have a gray. The neutral of a 480 system is commonly gray. This is on a testimonial. Please keep this one if you don't want to remember it. It's not code commonly industry standards. I just want to remind you guys the code says the following. If your building, commercial building, has two voltage system in it, not one, as in 48277, 28120, commonly used all the time, then you have to identify the phases by color and the system by color. And you have to identify, so if I have two voltages coming to the building, I have to use this system. Not these colors, but identify every system by color, and also right here, by color, and every system by color, by phase and by color. So I can't have red here and red here. They have to be, the phases have to be different from each other, here, and the system have to be different from each other. And you have to put a label on every panel in your building with this information that indicate this information. Meaning, if you're going to be using black, white, red, blue as your 208, and yellow, brown, orange and gray as your 480. Be aware of this one, because Eric, my friend, will be installing in your projects. They will ask you for a label. You're going to come up with a label that label the color coding for the system if you work for electrical contractors especially. The green continue to be for everything, for the two systems. Now what happens if you have 24120 delta? You can come up with pink, any color that's not white, gray, or green. Any question guys about that? Yes, sir.
You said the 208, 120, you have black, blue, red, white, and also green.
The green is the ground. The green goes with everything. The green, guys, I left the green here because the green goes with this system and goes with this system. The green is always ground.
So it's white.
Yeah, it's all, yes, if you're using cables. But if you're using conduit, then you need to pull 4 wires because the conduit itself will be your grounding. Yes, if you're using cables, you need 5 conductor for a 3-phase system. Any questions about this? Very important. Very important. Just FYI, what you're looking here is, what color is this, Muhammad? Blue. This blue color, my friend, is the neutral in Europe. So if you get a machine from Europe and you see a blue in it, and which you're going to encounter all the time, Brad, you're laughing, you'll see it, you know. Yeah, the blue, if you're encountering, you have to be aware of that one. If you're encountering an outside the US standard, not confusing people, but enlighten them to the international world, buddy. So if we have a blue conductor coming from Europe, be aware that this will be your neutral coming from outside the US. Another thing, guys, in the past, if you went through, they used to use a gray as a hot conductor. So if you're doing remodeling in a building, Spencer, downtown, big building, you're going to tear down a switch gear, add another switch gear, and you see a gray conductor, always be suspicious. That gray conductor could be used as a hot conductor. So I have to remind me of that one. Okay. Yes, sir.
What size are those?
These ones, these are, I thought 4-aught. Yep. Thank you. 4-aught, all of them. So, yes, sir.
So in a situation where you might run into a gray conductor as a source entrance or whatever reader, what other color would be if you could go orange, or what's have you seen?
In an air, like you continue from a switch gear, the switch gear phase A is gray. See, existing, and you will add to it. Oh, what?
In your situation from the brand?
I have not ran into that. No, I have not ran into that. But what I thought, what if you ran into it and if you don't want to replace it, if the gray is used as phase A, you don't want to use a gray as a neutral. So you might have to use a white with, not a white or something else other than neutral. No, I have not seen it. Anybody? Mr. Bew, you have seen everything then. I've seen that one. No? Anybody? DJ? Yeah, so that's basically somewhere. A couple of things, guys. Mostly, Spencer, these are very expensive cables because they are color coded. Color coded, guys, any conductor 1 or larger, smaller than 1, they color code them. More larger than 1, most of them come as a black. Where is that black here? And what do you need to do? You don't have, then you just put a tape. This come as a black and you tape it white. And all of them come as a black and you just tape them with that particular color or paint them. So but the industry is moving more and more towards color-coded insulation.
I think
So-
it's not much more price difference anymore.
Yeah, they're if you go to Southwire, guys, they're pushing the color-coded insulation a little bit more expensive, but not by that much.
Can't mix up the
Yeah.
phase then.
You can what?
Can't mix up the phase then.
Yes, yes, absolutely. When you're pulling three black conductors, at the beginning you have to be very careful when identifying. It makes the electricians work much easier if it's the insulation itself is color coded. Okay, grounded conductor, guys. We talked about the grounded conductor, the neutral. It's basically gray or white. That's the most common, or outer finish, not green. Continuous stripes, some white stripes on it. The most common ones that you're going to see is white or gray. White 208 system, gray 480 277. Grounded conductor, guys. Here's your color for grounded conductor. Almost always you're going to have a bare green with one or more yellow stripes. So it's still green but has a yellow stripes on it. So if you see anything green or greenish or anything green with the stripe on it, especially yellow, that's a grounded conductor. Okay. So that's green. So that's basically what I wanted to mention, guys, about the color coding for the test tomorrow. Now using typical code color for conduit wires, we talked about this gray. This is what I talked, guys, about the two electrical system in one building. You have to identify by phase and by building, by phase and by system, by phase and by system. This is if you're using cables, Mr. Bab. If you're using cables, if you're using conduits, the color code that I gave you is always almost there. If you're using cables, here's how the industry, if you go to Southwire, this is how most of the industry standardize the cables, guys. And you don't have to memorize this, not on the test. If it's in the test, I usually ask you to go there. But if you have a two-wire cable, they go black, white, bare is the ground, and or green. So that's basically phase A, neutral, and a ground. Three-wire conductor, you have a black and a red. Now you added hot 1, hot 2, still neutral, and a ground. The same thing. You go to four-wire conductor, now we're getting into the three-phase system. You have your red, your blue, and your black, and you have your green for the ground, and you have your white for the neutral. Then four-wire cable, you have black, white, red with stripes and so forth, and all the way to another cable, the 5-conductor cable that you can use is you have a black, a white, a red, blue, and a yellow conductor with a green equipment ground conductor. But again, you can also, I believe, they make cables with these color codes too, with different. They make cables with a lot of color codes, guys, that you can use.
So what would you do with the white with the red stripe? Would that would go with the red one?
White with a red stripe, that will be identifying the neutral, will be identifying your neutral. You identify your neutral. So black, white, red, blue, yellow, green, or equivalent. Where do you see the white with white with red stripe? This is so we have a black. That's an interesting. Yeah, here's my hot. Here's my red, white with red stripes. Here's a white. I don't know why white. This we have an equipment ground conductor, so we know the neutral white with red stripes. Red stripes.
I've never seen that.
Yeah. White with, I don't know why would you white with red stripes. That would be another hot the way I look at it.
No, it says or.
Or.
Yeah, it
Or
does say
bare.
or bare
So it's
equipment
a-
ground.
For equipment, white
How can it
with
be
red
equipment
stripe
ground?
or
It's gotta be
bare
bare.
equipment grounding conductor.
I've never seen that.
Yeah. Black, white, red, white with red. Okay, so these are
Where's
the
the
two
black
phases
and
and the
blue?
neutral, and this one is going to be your white with red stripe.
I've always seen black and blue. White.
Anyway, the most common ones is what you guys are looking at. Any other comments? I don't know what we'd use it. Probably the way they're showing it right now, probably equipment grounding conductor, but it's bare green or green with yellow though. If you look at the definition, they didn't say it white with red stripes on it. Any question about this color coding, my friends? Color coding, Camille? No?
Just one, I don't know, it's kind of common practice. You have the black, red, blue, the blacks, phase A, reds, is B, and
Yeah.
blue is always C, and then it's always brown, orange, yellow, A, B, C.
A, B, C, neutral, ground. And where's the
And then
other
it's always
one?
brown, orange, yellow.
We don't have brown, orange, yellow here. We have it on the second. So, any question, guys? Any question about the color coding?
Boys, other one.
The other one. Let me go back here
Boys,
to
Brown, orange, yellow.
yeah, brown. Well, okay, so there was one slide that has the brown, orange, yellow. Black one. Okay. Very cool. Brown,
Brown, orange, yellow is different.
brown A, orange B, and yellow is C, and neutral. You guys want to write this one? Black is A, B, C, and in neutral. And a ground. Polly, did I get them right? Okay, so that's basically the typical if you guys want to write these. And these are for three-phase system color coding. Based on physics.
277
277 is
Brown,
this
orange,
system.
yellow.
The
Oh, 480,
the yellow.
277.
Yeah,
It'll be
270.
both.
This will be 480, 277.
It says you said that you can use the 480 and 277 with the same colors.
It's a system. It's a 2 voltage system.
Well, if you had two of them in one building, what would you do?
That's one system. 480, 277 is one system.
Right.
It's a neutral. It's a grounded system, neutral ground system. The other system is 28120. The other system is 208/120. Now you could have a third system, 24120. Then you have to come up with a different set of lights, of conductors.
Does that mean all these colors, black, white, red, blue, green, yellow, all that colors are for a I'm asking a question like that, how you know to identify to say what type of system is it? That means for a
Mr. Irbab, this system right up to, okay, so black, white, red, blue, this is the 208 system. And the yellow, brown, orange, and gray are the 480. The green is coming between both of them. The green, that green, you don't have to use different greens. The green is coming between both of them.
Oh, I see. Okay, it's two systems because I was thinking that 6 colors, all to the yellow are one system. So
Oh, no, they're two systems.
yeah, thank you.
Any question, guys? Any question, my friends? Okay, so we got these gray conductor. That's the caution that we talked about, the gray. Ryan, my friend, the gray being used as a hot conductor in the past. To electrical system in the building. Color coding for cables. Covers. Okay. All right, so this is just talks about, guys, the plates, face plates. If it's obviously it's raised, cover placed on surface mounted boxes such as 4 inches. If you have a raised cover, you have to attach the device to the cover with 2 screws by code. If it's metal, you have to ground it. It's grounded by being attached to the yoke and the box. If it's non-metallic, who cares about it? Here's one thing I want you guys to remember because it might be on the test. For metal face blades considered to be effectively grounded, if you put this size of screw that fasten them to the grounded yoke of the receptacle, 632. So if you attach your 632, it's considered grounded if it's a metallic box. If it's non-metallic box, who cares? It's not. You don't need to ground it. Okay. Okay. Stalled. Wet location. In wet location, guys. In wet location in 2008 and 2011, if you have receptacle or plugs in wet location, they have to be like every other. The receptacle in wet location in a commercial building has to have a cover that cover the plug as the plug is engaged in the receptacle. In 2011, they made it even worse. You have the heavy duty cover. That bubble that you use in residential no longer apply to commercial building. You have to have a heavy duty. So you see them all the time that opens this way, heavy duty big metal box in 2011. So you can't get away with that plastic bubble in a commercial building anymore, July 1st, 2011, if we adopt the code in Minnesota at that time. So that's what they say, the weatherproof enclosure that you need to have it. Weather resistant, I can't emphasize, Brad, not only the receptacle that you put them outside in wet and damp location, and Spencer and Holly, they are going to be special type of receptacles. If they're spec type receptacle, guys, most of the time they are weatherproof, but you have to make sure that it has this WP on them. Even we're outside the residential now. They added to the residential. In a commercial building, outside receptacle in wet or damp location, it has to be the WP on it. Weatherproof. Weatherproof. Weatherproof.
What did you say about the bubble during the deal?
The bubble in non-residential. Can you put that one? Non-residential. The bubble, you cannot qualify because it has to have heavy duty cover. And that bubble, plastic bubble, does not qualify as heavy duty.
So you're talking about metal.
Yeah, it will be a metal one that sits like this with a cover. So when you put your conductor, it's covering it. I have a picture. I'll show you a picture of it if you research it. It's a metal box, sits like this, but heavy duty metal box. I think they just get sick of that cover sitting there. Somebody kick it with their foot and break it. So all these receptacles, guys, have to be weatherproof if you put them in a wet location. So for our building, guys, the receptacle outside wet location, make sure that you tag them or somehow you identify them in your spec or somewhere else as a weatherproof receptacles. Subject to wet location, dry location, and wet location. This is, guys, just a definition, just to identify the cover that you need in a damp or wet location. You need this cover. And this is how they define, Brooks, my friend, what dampness is and wetness is. Wet is saturated with water. Dampness, well, you get wet sometimes. Dry, it's location not normally subject to dampness or wetness. Normally, you can sweep or you can clean the floor and it becomes wet, but that's not normally wet. So anyway, so dry, we know what a dry is. Wet is basically saturated with water, and damp is location protected from the weather, not subject to saturation with water or other liquid, but subject to modest degree of moisture. Basements, commonly places with that one. Any question, guys? Why do they define this, Mr. Ryan, my friend? Because in these locations you need a weatherproof receptacle. Inspector will catch you about that one. Weatherproof receptacle. With a cover, heavy duty cover, based on 2011. Heavy duty cover. Any question, guys? This is what I thought it's interesting to cover. Any question? Any question about that? I can't emphasize the location that you need GFCI, weatherproof receptacle outside, color code for the system. Very important, guys, especially if you want to take your career to the next level. Instead of being drafter, you're going to be a project manager, estimator. It would be really nice when you walk in and Holly, who I want to pick on, maybe DJ, can I pick on you? A smart electrician like DJ sitting there and say, oh, by the way, can you tell me what phase is this? And he's pointing a conductor like this. Is this phase A or B or C? So it's really nice to know the identification, guys.
You don't think I would
If you
do that?
can. Huh?
You don't think I would do that?
Oh, I had an electrician ask the engineer, what's the length of the screwdriver that I need right to mount that box into the wall? Just being smart, Alex, a little bit.
Okay.
It's so nice to prove the engineer wrong. I don't know if you guys know that. It's kind of it gives you pleasure. It gives some people pleasure to prove an engineer especially wrong, which it's not hard to do. That's what we have. Thank you guys for listening. I'm going to give you a break and then we're going to do a review for the test.